Welcome back to the Art of Math. Back by popular demand, we're going to do another mental math video. So today we're going to go over an algebra applications video on how to calculate perfect squares fast, which will be talking about mental math. So quick note, in this series, if you go to video number 4 on perfect squares, that's where we sort of begin talking about memorizing them and all sorts of other fun things. So if for those of you not familiar, just like joining us, you might want to refer to video number 4, or even if you've seen it, you might want to review it in conjunction with this video. So a little bit of a backstory before we get started, which is how this video came about. So I'm constantly learning from my students, and that's one of the reasons I love teaching students and interacting with them. So here's the origin of this video. So I asked a student to tell me what 21 squared is, and he thought about it for a bit and said, well, not for too long, and said 442. Now what he was trying to do is to split that 21 to do like 20 plus 1 times 20 plus 1, and so he was trying to do something clever, he just messed up. So obviously 1 times 1 does not end in a 2, so he made a little bit of an error, but he was basically the one that gave me the idea, you know, almost directly, slightly indirectly, but through his mess up, that like, wait, that's a really good way of doing it if you just get it right. So I guess I maybe thought, I wrote here, I never thought of this before. To be honest, I may have thought of, like, been aware of this, but here's the funny thing. Sometimes you know things, but until you try them, you never realize how effective or ineffective they might be. So for the first time, I actually decided to try this and see. So he was kind of really the inspiration. So I really want to thank him for that. So let's go back to this. So from practicing algebra and expanding, factoring, a lot of you should be comfortable with this. So x plus y squared is expanded into x squared plus 2xy plus y squared. So for our purposes, we're going to think of x as the nice part and y as the ugly part. So let's think about that. Let's say like we want a number like 23 squared. So how do you calculate this super quickly? Split it into the 20, the easy part, and 3, which is like that a little ugly bit. So, and we're literally going to expand this the same way we do here. Now, I've written it all out here, but I want to stress the whole point of doing this is that it should be easy enough to do in your head. So I'm just going to run this through in our heads and then just show you on paper. So 20 plus 3 squared using this would be the 20 squared, then 2 times x and y, so 2 times the 20 times the 3, and then the 3 squared. So that'd be 400 plus twice 60, so that's 120. So now we're at 520 plus 3 squared, which is 9. So that's 529. And I've just, for all of these, written that out here. So 400 plus 120 plus 9, 529. So you can do that for any perfect square. I've picked a lot of two-digit perfect squares here. So for 24, again, split it that way, double the 20 times the 4, boom. So all of these should be really easy to do. So 29, any two-digit number you want. So like 29, 20 plus 9, 20 squared, 2 times 20 times 9, just following this recipe. And then we have, again, you should be able to do this in your heads. 841. Here's a little bit of a cool note. For 29, because it's so close to 30, we can actually go backwards, and that might be faster. Maybe not. It might not be worth the trouble, but just to show you guys the idea, you can represent it as 30 minus 1 instead of the 9. And then that way you have slightly easier numbers. So 30 squared is 900, and then 2 times 30 times 1 is minus 60, and then this part is just a 1. So that's another way of getting this 841. So just giving you guys options. 57, same thing. So the 50 is the easy part or the nice part, the 7 is the harder, ugly part. So that's basically what I wanted to show you guys. So now if you want to calculate anything, like 28 squared, so that would be the 20 plus the 8, and that whole thing squared. So it'll be 400 plus 2 times 20 times 8. So that should be 320 plus another 64. So that's 720 plus 64. So 784. Hopefully I got that right. All right. Now, for those of you that just want the basics, that's the meat of the video. However, for the superheroes among you, you might be wondering, like, wait, you gave me two-digit numbers, but you said this works for everything. This does work for everything, but let's see how practical it is. So if you want, you can try to apply this to three-digit numbers. Let's see what would happen. So our 3-digit number we might want to split into 3 parts, A, B, C. So for example, 137, your A would be 100, your B would be 30, your C would be 7. Now here I've just written out this more annoying expansion. So if you multiply everything out here, you'll get A squared plus 2AB plus 2AC plus 2BC plus B squared plus C squared. I've written the sad face here because, okay, yeah, we can do it, but honestly, like, I'll be honest with you guys, I'm a mental math hero just like a lot of you guys, but this is too annoying. I'm not gonna use this in practice. So while it was fun to think about it, if I had to do this, I'd probably just do this on paper or on a calculator. But you could do it, right? Like it still might be easier than just doing it the paper way in your head, but I don't know. This, to me, it's like, it's so complicated at this point that it's almost not worth it. So before we abandon this, let's just try to salvage this method. So what if we split it differently? What if we take the 137 and do 130 plus 7? So basically we're going to do the same thing, except now the easy part's a little uglier. So it's not as easy. Or we can do 140 minus 3 going backwards. So I'm just going to pick this one. So let's say we have 130 plus 7 squared. Well, this is not too bad. We can actually do 130 squared because that's like a 13 squared with 2 zeros. So that's going to be 169, and that's going to give us 2 zeros. So 16,900 because we know our perfect squares. So that part's fine. This part's relatively fine. It's 2 times 130 is 260. 260 times 7, a little annoying, but we can do that. That's 1820 in our heads. 7 squared is 49. So you could do this in your heads and get 18,769. Like, to me, it's kind of getting to the point where it still might be better than the usual thing of just doing the old-fashioned paper way, but I'm not as excited. So that's why I put the sad face and my brain hurts. So, but it's worth a shot. Like, even just exploring this, hopefully you guys are seeing like, oh, when should I not use it? When should I use it? Just thinking for yourself, because then you're making this your own and not just copying something I've told you. So here's my challenge. And I want to warn you guys, you might not want to spend too much time on this because the answer might be no. So see if you can find a better approach. Maybe something other than these two, other than number 1 or number 2, or regular multiplication that would, so basically like a fast way to calculate perfect squares for non-2-digit numbers, like 3-digit numbers, 4-digit numbers. Maybe there's another way we could split it. Maybe there's some other trick I'm unaware of. Just think about it. Like, even if you fail, spend 5-10 minutes, if you want an hour, whatever you guys want. It could be 2 minutes. Just think, like, how else might we approach this? Maybe for 137 we'll start with 200 and subtract 63. I don't know. Whatever. Or maybe we'll split it into completely like other things that I haven't thought of. So that's my challenge to you guys for those that want to play around, and I will see you guys in the next video.